Hello students, welcome to the class of software engineering. In today's session, let us discuss about requirements engineering process. So we have studied about the functional and non-functional requirements. Let us see the difference between functional and non-functional requirements. So we have the first column represents the functional requirements. Second column represents the non-functional requirements. Functional requirement defines a system or its component. So what does it mean? Functional requirement mainly defines what service your system should provide or what functionality your system should provide. Whereas in the case of non-functional requirement, look at that column. A non-functional requirement defines the quality attribute of a software system. It mainly defines the quality of your software system. It can be either efficiency or availability or performance of your system. Second one, under functional requirement, it specifies what should the software system do. Means what your system should provide, what functionality it should provide, or what services it should provide. Under non-functional requirements, it places the constraints. So it is nothing but the constraints on how should the software system fulfill the functional requirements. Functional requirements are actually statements which say what services your system should provide. So you will develop your system based on those functional requirements. But we need to see whether your system fulfills the functional requirement, that is by measuring the performance. So that is non-functional requirement. Functional requirement is specified by user. Functional requirement is specified by the user. So these functional requirements are given by the user, whereas non-functional requirements is specified by technical peoples like architect, technical leaders, and software developers. Next, under functional requirements, it is defined at a component level. So you are taking each component and showing that that component will specify or will provide the functionality. Non-functional requirements means is applied to a system as a whole. So non-functional requirements will not be applied to each component. Instead, it will be applied to the entire system as a whole because we are taking the performance of the entire system. Okay. Finally, your system should work correctly. Next difference, functional requirements helps you verify the functionality of the software. So mainly it helps you to verify the functionality of the software, whether it has satisfied all the functionalities. Under non-functional requirements, it helps you to verify the performance of the software. You're going to see the performance of the software. So next difference is the example 1. Authentication of user whenever he or she logs into the system. So here, see, whenever you log into the system, you will put your password. So that is mainly to authenticate whether you are a valid user or not. So that is one functionality, functional requirement. Second one, system shutdown in case of a cyber attack. Suppose there is a cyber attack, then your system should shut down. Third one, a verification email is sent to user whenever he or she registers for the first time on some software system. So wherever you register, do the registration process in any site. So what happens? Immediately your registration is successful, you should get a mail from that, isn't it? Okay. Non-functional requirements will take the example. Emails should be sent with a latency of no greater than 12 hours from such an activity. Now in functional requirement, I've specified that whenever you register for any site or any job, you should get an email confirmation. But I've not told the time constraint. So here, within 12 hours, you have to receive the email. Second one is the processing of each request should be done within 10 seconds. So you need to process the transaction within 10 seconds. So each request. So like for example, your mobile phone only you take, you have authentication there, isn't it? So you can unlock your mobile using the password or any fingerprint. So if once it goes wrong, immediately it will ask re-enter, isn't it? One more time it will ask. So 3 to 4 times within a fraction of seconds it will ask. And again after 3 or 4 times it might get locked, and within some 1 minute durations, after 60 seconds again you can enter. Clear? So even the transactions also within a second, your transaction should be completed. The site should load in 3 seconds when the number of simultaneous users are greater than 10,000. So suppose the site is being used by more than 10,000 people, then your site should be able to load within 3 seconds. So that is the performance. So which indicates your non-functional requirements. So these are the differences between functional and non-functional requirements. Simple one, you take your Amazon site. So that website has been designed. Okay. So what were the requirements? All those requirements might have been given by the customer or the user. They have designed the Amazon site, isn't it? And later on, they had put the feedback session where they will get the feedback. They can do some modifications. So, but only providing functionality in that system is not enough. They are satisfying the non-functional requirements. Can you identify which one? See, they are providing all functionality. Like you can shop any type of brand there, isn't it? You can do clothes shopping, bag shopping, laptop shopping, mobile shopping, every variety. Okay, but that was their main idea to put into their site. But the thing is, their site became successful or became famous. Why? Because of they achieved the non-functional requirements. What they have achieved, you only can tell. Because see, the immediate you order your product and you do the payment, so immediately you get a confirmation mail also that the payment has been done. Correct? Yeah. And even it will tell about your package, where it is. Track your package you have. See how many features, which helps you to know when your package will be coming to the door. Okay. Also, once the day you receive the package, again you will get a mail that your product is out for delivery. See how convenient it is. Then it is being delivered. Once it has been delivered, you get an email there. And suppose you are canceling your product, again immediately you'll get an email confirmation message saying that your product has been cancelled. Everything is done within a fraction of second, and your money will be also refunded back. Your money will be also refunded back. So you, mainly your system should become popular means you have to achieve these non-functional requirements. So only satisfying functional requirements is not enough. So that's why I told you have to fulfill the requirements. Next, we'll see about requirements engineering process. So requirements engineering process includes 4 level activities. We have already seen about it. These focus on assessing if the system is useful to the business. So these focus on assessing if the system is useful to the business. So that is feasibility study. We are making an assessment whether the system is useful to the business or not. Then we are discovering the requirements. That is nothing but your elicitation and analysis phase. You are discovering the requirements and analyzing it. Then you are converting these requirements into some standard form, and that is called specification. That is your requirements documentation. So you're collecting all the requirements, analyzing it, and put it into some standard format or standard documentation, which is called the requirements document. So that happens in the specification phase. And checking that the requirements actually define the system that the customer wants. That is validation. So here we are checking. Here we are checking whether whatever requirements we have defined and implemented will satisfy the customers. So will actually satisfy the customers' requirements. So that is validation. Now we'll see the spiral view of requirements engineering process. So this is actually the spiral view. So you can see here one thing is the here we have the spiral view. So requirements engineering is an iterative process in which the activities are interleaved. So you can see in this figure the activities are interleaved. The activities are organized as an iterative process around a spiral with the output being a system requirements document. So the amount of time and effort devoted to each activity in each iteration mainly depends on the stage of the overall process and the type of system being developed. So we can see here early in the process, when I start from here, early in the process, most effort will be spent on understanding high level requirements. So business requirements are nothing but high level business and non-functional requirements. So that is the start. And the also the user requirements also. Okay, for the system. Later in the process, in the outer rings of the spiral, more effort will be devoted to eliciting. So where is your eliciting? Here. So eliciting the requirements, okay, and understanding the detailed system requirements. So the number of iterations around the spiral can vary. So the spiral can be exited after some or all of the user requirements have been elicited. So you get the finally the requirements document. So you can see first you begin with user requirements specification, and then you're eliciting the user requirements, then the system requirements, and finally you get the requirements specification, and then you're doing the requirements validation. You're validating all those requirements, and finally you get the requirements document. Whatever you need, that is the requirements document. Here. So we'll see regarding the requirements elicitation and analysis phase. See, after, yeah, so here actually, after the initial feasibility study, the next stage of your requirements engineering process is requirements elicitation and analysis. Already in the previous videos, you have seen the entire requirements engineering process. So it begins with feasibility study. After feasibility study, you have the requirements elicitation and analysis phase. So in this phase, what happens is your software engineers, they work with the customers and system end users. Those who are system end users means those who are going to use the system. So here the software engineers work with the customers and system end users. Why? To find out about the application domain. So what domain should be used in their application? what services the system should provide, what functionality should provide, what should be the performance of your system, what are the constraints, it can be hardware constraints, etc. Okay. So this phase involves a variety of people in an organization, I can tell. So we have something called stakeholder. So this is an important term in software engineering. What is this? Who is a stakeholder? See, a stakeholder refers to any person or group who will be affected by the system directly or indirectly. Okay, who will be affected by the system directly or indirectly. So, a system stakeholder is anyone who should have some direct or indirect influence on the system requirements. So either they are influencing directly on the system requirements or indirectly on the system requirements. Stakeholders include end users who will interact with the system and anyone else in an organization who will be affected by it. Will be affected by it. Now we will exactly see what all process activities are involved in this elicitation phase so that you will get an idea regarding it. So look at the first process activity, requirements discovery. Requirements discovery means, see, this is the process of interacting with the stakeholders. So now you know who are stakeholders, who either directly influence the system or indirectly influence the system. So in requirements discovery stage, what we are doing is the software engineers, they should interact with the stakeholders in the system. Why should they interact? In order to collect their requirements. So discovery means you have to get the requirements, isn't it? So to collect their requirements, you have to interact with the stakeholders. Second one, requirements classification and organization. So now see, you have got the requirements, correct, from the stakeholders, but they might be in unstructured way. So what you have to do is you have to now group them, that is classification, group them into related requirements. First you have to group them into related requirements, that is classification, and organization means organizing them into coherent clusters. So whatever requirements you have discovered it here or collected needs to be put into a structured way. So what you have to do is you have to go for classification. Means group them into related requirements. Group them into related requirements and then organize them into coherent clusters. Now third one, requirements prioritization and negotiation. Requirements prioritization and negotiation means this activity is concerned with prioritizing the requirements. So what does this activity is concerned with? Requirements prioritization. You are giving the priority to the requirements which you have classified and organized, and finding and resolving requirements conflicts through negotiation. Negotiation is there, some compromise you have to come to. So you are finding and resolving requirements conflicts through negotiation. And then last you have the requirement specification. So here the requirements are documented. Requirements are documented and given as input to the next round of the spiral. So here the requirements are documented and given as next input to the spiral, next round of the spiral. Okay. So these are the process activities involved in your elicitation and analysis phase. Next, this is a very important question. Eliciting and understanding requirements from system stakeholders is a difficult process for several reasons. Now, we told that you need to collect the requirements from the stakeholders. But one important thing here is to understand the requirements from given by the stakeholders is a bit a difficult task. Why? Let us see. First point, stakeholders often don't know what they want from a computer. Stakeholders actually often don't know what they want from a computer system except in the most general terms. Okay, so it's like I can tell stakeholders find it difficult to articulate what they want the system to do. They actually know stakeholders will be giving their ideas, telling that this should be implemented in the system or this functionality should be provided by the system. But they find it difficult to articulate what they want the system to do. Okay, so stakeholders in a system naturally express their requirements in their own terms and with implicit knowledge of their own work. So, requirements engineers without experience in the customer's domain may not understand these requirements. So, keep in mind, stakeholders in a system naturally express requirements in their own terms. So, they express the requirements in natural language. But you know that this in this requirements phase, who are they? Who are the people involved? Requirements engineers. They actually don't have any experience in the customer's domain. They may not understand those requirements. Third reason, different stakeholders have different requirements and they may express these in different ways. So different stakeholders, if you consider, they will be having different requirements. Their opinion is different. So they may express in different ways. Now, what happens to the requirements engineers? They're working on these requirements. No? They have to discover all potential sources of requirements. They have to discover all potential sources of requirements. Next point. Political factors may influence the requirements of a system. There is also chance of political factors influencing the requirements of a system, like managers may demand specific system requirements. So now even the political factors. So political factors like manager will be managing the entire project. So he may demand specific system requirements. He might give his requirements because these will allow them to increase their influence in the organization. So like they might think that if the system is built according to their requirements, so they will have more power in the company. Fifth one reason is the economic and business environment in which the analysis takes place is dynamic, Okay, so it inevitably changes during the analysis process. So the importance of particular requirements may change. So new requirements may emerge from new stakeholders who were not originally consulted. So some stakeholders might have come in between. So they might put their own requirements, new requirements. So that leads to some confusion. So these are the reasons of understanding the requirements from stakeholders is a difficult task. It's a difficult task. Now we'll move on to requirements discovery stage. Okay, so what do you mean by requirements discovery? It's also called as sometimes it is also called as requirements elicitation. So it is the process of gathering information about the required system. It's nothing but gathering information means collecting the requirements, what your system should do, and distilling the user and system requirements from this information. So you're trying to get the user requirements as well as the system requirements. Stakeholders range from end users of a system through managers to external stakeholders also can be. Now one simple example we'll take. We will discuss the stakeholders for MHC PMS system. So already you have seen the MHC PMS system. You have known about this system already. So who will be the stakeholder for this system? First one is patients. So they have direct influence on the system. So patients whose information is recorded in the system, isn't it? Patients for whom those who are suffering from mental health problem, they are being treated. So they are the stakeholders. Patients are the stakeholders. So their information is recorded in the system. Second one, doctors will be treating those patients suffering from mental health problems. Third one is nurses. Nurses actually they will coordinate the consultations with the doctors. Okay, so they will coordinate with that one and administer some treatments. One more stakeholder, medical receptionist. They will manage the patient's appointments all. And one more, IT staff. So this is indirectly who are responsible for installing that MHCPMS system needs to be installed properly and maintained, isn't it? So that is done by the IT staff. So they are the stakeholders. So these are the stakeholders for the MHCPMS system. Next, we'll see the different techniques of requirements discovery. Different techniques of gathering the information. We have first one, viewpoints. Second one, interviewing. Third one, scenarios. Fourth one, use cases. And fifth one is ethnography. We'll begin with the viewpoints now. What are these viewpoints? The requirement sources. Who are the requirement sources? Stakeholders, domain, systems. Okay. Can be represented as system viewpoints. So they are the system viewpoints where each viewpoint presents a subset of the requirements of the system. So I can tell that each viewpoint presents a subset of the requirements of the system. So they can be your stakeholder, domain, system. So there are three types of viewpoints we'll see. First one is interactor viewpoints. Second one is indirect viewpoints. Third one is domain viewpoints. First one, interactor viewpoints. What do you mean by interactor viewpoints? These viewpoints represent people or other systems that interact directly with the system. So these represent the people or the other systems that interact directly with the system. For example, you consider bank ATM. The interactor viewpoint will be who? Customers, okay, and customers. Now, second one, indirect viewpoint will take. These represent the stakeholders who do not use the system themselves. They do not use the system, but they have some influence. Okay, they are going to influence the requirements in some way. For example, you take bank ATM, okay? Indirect viewpoints, the bank security, ATM security staff is there. He may not be using the system, but he is going to influence on something, some requirement in that system. What it can be? Security. Okay. Third one, domain viewpoints. So these represent the domain characteristics and constraints that influence the system requirements. So these represent the domain characteristics and constraints that influence the system requirements. For example, same bank ATM will take. Domain viewpoint will be what you know, the standards that have been developed for interbank communication. So domain viewpoints mainly they represent domain characteristics and constraints. So I'll just tell for bank ATM, you know that system has been built, isn't it? So the domain viewpoint there is what are the standards that have been developed for interbank communication, isn't it? So a particular ATM system is communicating with a particular bank. So how is it possible? That domain standard is being specified here. Next, we'll move on to interviewing. So first type over viewpoints. Now next one is interviewing. Informal or informal interviewing, we'll consider formal or informal. The requirements engineering team, in short I can tell RE. RE means requirements engineering, puts questions to stakeholders. Now this interviewing means it can be formal or informal. The requirements engineering team, so nothing but the requirements engineers, they put questions to stakeholders about the system that they currently use and the system to be developed. So they will put some questions to the stakeholders based on their requirements. So requirements are derived from the answer to these questions. So what they do is they put some questions to the stakeholders regarding the new system to be developed. So from that, whatever answers they get, isn't it, to the questions being asked, they are going to gather the requirements. So this is another way of discovering the requirement. First one is viewpoint. Second one is interviewing. Now, interviews may be of two types. One is closed interviews. Another one is open interviews. What do you mean by closed interviews? Where the stakeholder answers a predefined set of questions. So closed interviews means the requirements engineering team will put forward some standard questions. So the stakeholders need to answer that. The stakeholders answers a predefined set of questions. Next, open interviews. Open interviews means there is no predefined agenda here. There is no predefined agenda. A range of issues are explored in stakeholders, and based on that issues there will be discussion. Okay, so here there is nothing like questions asking. They are going to consider the range of issues that is being discussed with the stakeholders so that there is better understanding of the user needs. There is better understanding of the user needs. Now, interviews in practice, how it can be is normally a mix of closed and open interviewing you can have. Normally, a mix of closed and open interviewing you can have. And also, interviews are good for getting an overall understanding of what stakeholders do, how they might interact with the new system, and the difficulties that they face with current systems. Okay, so interviews are good for getting an overall understanding of the system. Interviews are also not good for getting an overall understanding domain requirements. Why? You don't understand the domain requirements there. Reason is requirements engineers they cannot understand the domain specific technology. They cannot understand. Second point is some domain knowledge is so familiar that stakeholders either find it difficult to explain or they think it's not worth mentioning. So some domain knowledge is so familiar that stakeholders find it difficult to explain. Okay. So I can tell that effective interviewers, okay, they have two characteristics. First thing is effective interviewers have two characteristics. First one is interviewers should be open-minded. Open-minded means they should be always willing to listen to the stakeholders and they should not have preconceived ideas about the requirements. Second characteristic is they should prompt the interview to start with a discussion. Better to start with discussion or a project proposal. So they have to start the interview with a discussion or a project proposal, or begin to work with prototype if they have, and should not simply expect them to respond to questions such as tell me what do you want. Such type of questions no need. You have to directly come to either discussion or project proposal or put the prototype. Okay, that is about the interviewing. Next, we'll see scenarios. Scenarios. So, what are scenarios? Scenarios are real life examples of how a system can be used. So, scenarios are real life examples of how can you use the system. So, what they should include? First one, a description of the starting situation. So, first you have to include the starting point. Second one, a description of the normal flow of events. So you need to show the normal flow of events there. Third one, a description of what exactly can go wrong. So that also you need to specify a description of what can go wrong. Then information about other concurrent activities. So at the same time, what other activities are running, you need to specify. Then a description of the state when the scenario finishes. So you need to explain the state of the system once the scenario finishes. So next we will see an example for this scenarios. Let us see the example for scenarios. First, initial here we have the example for the scenario. So it is for your same MHC PMS system. Okay, MHC PMS system. So first initial assumption, initial state I have told. The patient has seen a medical receptionist who has created a record in the system. So this is the initial state. The patient has already met the medical receptionist. Medical receptionist has created record for that patient and collected all the details of the patients like name, address, age, etc. Now a nurse is logged on to the system and is collecting medical history of the patient. Now normal situation you need to, normal flow of events you need to explain. The nurse searches for the patient by family name. If there is more than one patient with the same surname, the given name and date of birth are used to identify the patient. So now actually nurse logs on to the system and will be searching for the patient's history. So first how the nurse will search the patient's details by the patient name. So names can be same, so better to begin with the surname they are searching. And if not possible, then the date of birth. Okay, that is kept as unique. The nurse chooses the menu option to add medical history. To add the medical history, the nurse will choose the menu option where it is add medical history. The nurse then follows a series of prompts from the system to enter information about consultations. So now nurse will click on that add medical history. So now nurse can enter all the information. There can be free text input. Existing medical conditions. Nurse selects conditions from menu. Medication currently taken. That also it's selected from menu. Allergies, free text, and home life. So that is the form. All those. The nurse will fill. What can go wrong now? So another uh, thing in the scenario should be a description of what can go wrong. So the patient's record does not exist or cannot be found. Things like the record is not found if it displays. The nurse should create a new record and record again the personal information. Patient conditions or medication are not entered in the menu. So in the menu it won't show the medications. Okay. Then the nurse should choose the other option and enter the text. So she has to type the text. Otherwise, directly select from the menu. Patient cannot or will not provide information on medical history. The nurse should enter free text recording the patient's inability or unwillingness to provide information. The system should print the standard exclusion form stating that the lack of information may mean that treatment will be limited or delayed. This should be signed and handed to the patient. Next step in scenario is information about other activities. At the same time, any concurrent activities are running, you need to see. So, record may be consulted but not edited by other staff while information is being entered. So, once the information nurse starts entering the information, that should not be edited by other staff. System state on completion. When the scenario finishes, user is logged on, the patient record including medical history is entered in the database. A record is added to the system log showing the start and end time of the session and the nurse involved. So here it shows which nurse has been involved and the login time and logout time. Next type of requirements discovery is use cases. Use cases. So use cases are nothing but a scenario based technique in the UML. They are also scenario based technique in the UML. UML is a unified modeling language, a standard graphical notation, which will mainly identify the actors in an interaction and which describe the interaction itself. So use cases are mainly going to identify the actors involved in an interaction and also will describe the type of interaction. We'll take the same MHC PMS system and use case for it. See here the stick figures represent the actors. Keep in mind the stick figures represent the actors and this ellipses, they show the interaction. Okay, they show the interaction. So we have one actor, medical receptionist, another one nurse, another one manager, then doctor. So medical receptionist, what is the type of interaction? It's shown in this ellipse. Register patient means medical receptionist, once the patient enters the clinic, will register that patient and also can view the personal information. Nurse can view the record of the patient, edit record, can also edit the information. Okay, then manager we have. Manager can view the personal information of the patient, export statistics, all the statistical data. Okay, what drugs has been taken, when it has been taken, what was the appointment made, everything, and will generate the report. So doctor will actually set up the consultation with the patient and also doctor can generate the report which in turn will go to the manager. Clear? Next next requirements discovery type of requirements discovery is ethnography. Ethnography. So what is this? This is an ethnography is an observational technique that can be used to understand the operational processes. So ethnography is nothing but an observational technique where you're going to observe the system in its operational environment. So here the analyst immerses in the working environment. So they're going to take the system in the working environment where exactly you're going to use the system and the analyst will work in that one. So where the system will be used and will give the day-to-day observation report. So an analyst observes day-to-day work and discovers the system requirements that reflect the actual ways that people work rather than the formal processes defined by the organization. So instead of so here the analyst will also be in the working environment, will analyze the system and will observe the system day to day and will note down what actually uh, what how exactly the system is used or system works. Instead of just seeing the requirements document or whatever standard procedures, instead of reading all those, better it's to observe and analyze the system in the real environment. So ethnography is effective at discovering two types of requirements. One is requirements that are derived from the way in which people actually work rather than the way in which process definitions say they ought to work. So usually if you go through one system now, I can tell of air traffic control system, you will just read the procedures, and after you read the procedures and you think, you imagine that this way it works, you think, but actual how it works you don't know. So that is more important. The actual way is needed more. So people need to focus on that one. For example, air traffic controllers may switch off a conflict alert system that detects aircraft with intersecting flight paths, if there are intersecting flight paths, even though normal control procedures specify that it should be used. Okay, they deliberately put the aircraft on conflicting paths for a short time to help manage the airspace. So according to the normal procedure, like in textbook if you read, it tells that it should be switched off, the conflict alert system, because it is going to detect yeah, it should be switched on. Yeah, sorry, it should be switched on because it will detect the aircrafts with intersecting flight paths. But what the controllers do, air traffic controllers, they switch off it. Why? They deliberately put the aircraft on conflicting paths. They deliberately put the aircraft on conflicting paths for a short time to help manage the airspace. So, their control strategy is designed to ensure that these aircrafts are moved apart before problems occur and they find that the conflict alert alarm distracts them from their work. So their control strategy is designed to ensure that these aircrafts are moved apart before problems occur. Second one is requirements that are derived from cooperation and awareness of other people's activities. So we are going to derive the requirements from cooperation and awareness of other people's activities. For example, air traffic controllers may use an awareness of other controllers' work to predict the number of aircrafts that will be entering their control sector. So the air traffic controllers, they may use an awareness of other controllers' work. They can use the awareness of other controllers' work. Why? To predict the number of aircrafts that will be entering their control sector. They then modify their control strategies depending on that predicted workload. Now, this diagram explains that ethnography can be combined with prototyping. Already you know about prototyping. So you can see here is we are combining ethnography with prototyping. So you have ethnographic analysis. You are analyzing your system, putting it into the real environment, making it to work there. So debriefing meetings, you are holding the meetings. Then here happens your focused ethnography, and then it is combined with system prototyping. So here you have the sample model, isn't it? So this model actually you're going to place in that working environment, and then you're applying focused ethnography. You're observing it, analyzing it, and then finally you can, by that observation, you can evaluate the prototype. So the ethnography informs the development of the prototype so that fewer prototype refinement cycles are required. Furthermore, the prototyping focuses the ethnography by identifying problems. It can identify the problems and questions that can be discussed with the ethnographer. Okay, so here same thing happens here. Okay, so you have system prototyping, it's nothing but a sample model. So focused ethnography is combined with the system prototyping. So both are they can hold meetings, so they can identify the problems and questions that can then be discussed with the ethnographer. He or she should then look for the answers to these questions during the next phase of the system study.